Hello friend, hope you are doing well. Today we are going to explore three important concepts in networking: VLAN, trunking, and spanning tree. I believe that regardless of our level, we always use these three concepts everywhere. Let's talk about LAN before we go to the VLAN. Cisco defines the LAN include all user device, server, switch, router, cable, printer, so on, and they are connected together, allow communication, transferring user data. In additional, we had another definition of LAN lines. LAN include all device in the same broadcast domain. The definition help us can explore the VLAN concept easier. A device in a broadcast domain can send a broadcast frame, and on device in the broadcast domain will get a copy of the frame. From perspective, we can think the LAN and broadcast domain is same thing basically. Now let's think about relativity between VLAN and switch device. On the Cisco switch, on box belong to the VLAN 1 by default, and without any VLAN, a switch consider on interface to be in same broadcast domain. And when the broadcast frame entered the one switch box, the switch forwarded that broadcast frame out on the other box. With this logic, we might need the two switch device if we need the two different broadcast domain, right? It's correct logic, but do not optimize, especially for designing. So the VLAN is created to support the multiple broadcast domain on the single switch, and the switch can configure the some interface into one broadcast domain and others interface into another one. For example, I can create two VLAN on a single switch. Um, VLAN 10 and VLAN 20. Box 1 and box 2 will be assigned to the VLAN 10, so they belong to the broadcast domain 1. And box 3 and box 4 assigned to the box VLAN 20, so it belongs to VLAN broadcast domain 2. About the technical, the multi-VLAN on the single switch have limited the number of hosts receive the unnecessary broadcast frame. A device in different broadcast domain cannot talk to each other. This have reduced security risk in some case. And about the benefit, the VLAN have saving the costs for the network operating. Summarize, VLAN allow us to separate the physical network to the multiple logical network. One logical group is one group of user device, same like a single LAN, and each group will be isolate each other. With the VLAN on the single switch, configuring VLAN is simply assign box to the VLAN. But when we have the multiple switch, process become more complex. For example, let's imagine you are a network engineer. Your company has the office on the 10th floor and 11th floor, and you have a switch at 10th floor and another one at 11th floor. To enable communication between users on these two floors, you need to connect the switch together. And in this case, another concept required to forward the traffic between the switch. This concept is called the VLAN trunking. The greatest benefit of using a trunking link is increasing the scalability of the network. If we don't have the trunking link, which each VLAN, we need each physical cable between switch to carry the traffic of the VLAN. Let's imagine one more time, if your network has 4 VLAN on the on switch at 10th floor and 11th floor, so you need the 4 interlink floor cable per the 4 VLAN, right? This is really a nightmare in case we have the 10 VLAN and the switch are different location. But if we use the trunking link, we just only need the one physical cable for the on VLAN between the those switch and resolve problem easily. VLAN trunking link between the switch support as many as VLAN we need, and it keeps the VLAN traffic separate. So frame in the VLAN 10 cannot go to device in the VLAN 20 and vice versa, because each frame is identified by the VLAN number or the VLAN IDs as it cross the trunk. Should we add or touch in a small header to the Ethernet frame and forward the frame on the trunking link? The header includes the VLAN ID, so when the remote switch receives frame, it checks header and understands that the frame belongs to VLAN 10 or VLAN 20. It removes the VLAN header, forward the original frame out its interface based on the MAC array table. To support the trunking feature, Cisco switch has two different trunking protocols: Inter-switch links (ISL) and IEE 802.1q. ISL is a Cisco proprietary protocol and is created before 802.1q had notified yet. And nowadays, .1q has become the more popular trunking protocol in networking. About operation, both of protocol task each frame with a VLAN ID. Insert the 4-byte VLAN header into the original frame. Within 10 bit VLAN ID field is a matter with 10 bit. Will support the 2 power of 12 VLAN ID. So we had 4096 VLAN ID. But in practice, it's about maximum 4094. Two values are received 0 and 4095. Cisco set the working range of VLAN ID into the two range. Range 1 from value 1 to the 1005, and another extended from 1006 to 4084. Okay. .1q define the one special VLAN ID on the each trunk, call it native VLAN. Default use VLAN 1 in Cisco switch. .1q does not add header to frame in the native VLAN. When the switch on the other side of trunk receives a frame that has the header, .1q header, the switch knows that the frame is part of native VLAN. So with this behavior, both switch must raise which VLAN is native VLAN. So we need to configure the same native VLAN ID on the board of switch. If not, the switch will prompt the error mismatch native VLAN. Native VLAN provide interesting function mainly to support the connection to devices that do not understand trunking. A common example: a connection between switch and the wireless access point. Okay, nowadays VLANs is divided into the two main types, data VLAN and the voice VLANs. Data VLANs configured to carrier user traffic, and the voice VLAN, same like its name, carrier the IP voice traffic from an IP phone. And in additional, we had the some VLAN type like default VLAN, management VLAN, depending on the user definition. Okay, because the VLAN isolate communication between hosts in the different groups, so the hosts in same VLAN can talk each other and cannot talk to the hosts in different VLAN. But when we incorporate VLAN into the enterprise networks, the device with this VLAN sometimes need to communicate with the device in the other VLANs. For example, if I am in the VLAN 10 and printer in the VLAN 20, sometimes I want to bring a document, so this requires allowing traffic between VLAN 10 and VLAN 20, right? To forward the packet between the VLANs, the network must use the device and access a router or later switch. With the router case, router has the two physical links, one connect to the VLAN 10 and one connect to the VLAN 20. Or we just use one physical box and using the sub interface as well. We call this way is the routing on a stick. With this design, switch will still do its job, forward frame inside the VLAN, and the router do its job also, routing packet between the subnet of the VLAN. With the later switch, the diagram will be similar, and physical connection is same line layer 2, but the layer 3 switch has the capability to routing in additional switching. Okay, about configuration, LAN and trunking configuration are quite simple. To create the VLAN, we need to go to the config mode, and under config mode, we type the command VLAN and follow the VLAN ID from 1 to 1005 and from 1006 to the 4094, and then we move to the VLAN submode, and under the submode we can define the name of VLAN using command name follow the name of VLAN, and the name the VLAN name has a maximum length up to 32 character and must not include space special characters. If the name exceeds the 32 character, it will be truncated automatically and switch will show the alarm. This alarm checks the information and does not affect the VLAN function. Now, after we had the VLAN, we need to assign the VLAN to a specific port on the switch. We need to go to the interface submode and then type command switchboard mode asset, and then switchboard asset VLAN follow the VLAN ID we want. Command switchboard mode asset will inform the board will operate as a non-trunking board, and an asset board can belong to only one data VLAN. After we complete the VLAN configuration, we can use some commands to verify them. Example, show VLAN bridge, show VLAN ID, and show interface VLANs. In case we want to delete the VLAN, we can use command the no VLAN follow the VLAN ID. But before do the step, we need to assign the board to the new VLAN or the default VLAN, and then using the command. Also, we can delete all VLAN on switch using command delete flash colon VLAN dot. We had the two important notes here. In the Cisco switch, we cannot delete the VLAN default VLANs. VLAN 1 for Ethernet and VLAN for FTDI token ring from the 1002 to 1005, and another in the case we had to define the VLAN ID in the standard range from 1 to 1005. After this command, VLAN will set to VLAN database without the saving running config to startup config command. But in the case we use a static range, we need to set the configuration because static range ID will not say in the VLAN database after we exit the VLAN mode. So if the switch reboot, VLAN will be removed. Okay, trunking configuration also simple. To configure the trunk, we need to go to the interface submode and then type the switchboard trunk encapsulation .1q, and then switchboard mode trunk. In case we want to allow the specific VLAN on the trunk link, we type command switchboard trunk allow VLAN follow the VLAN ID. And if we want to change the native VLAN, we can use command switchboard trunk native VLAN follow the native VLAN ID we want. We can use command show interface trunk to determine which interface is the trunk mode, and verify the trunk configuration using the show run interface. And nowadays, some switch do not support the ISL encapsulation, so the command encapsulation .1q is no need. Okay, now go to the next topic today. As you know, switch using spanning tree protocol to prevent loss in network. With spanning tree, switch set is blocked in either forwarding or blocking state. Forwarding state start as normal, forwarding and receiving frame. However, blocking state do not receive any frame from except the spanning tree message. Do not learning MAC address of receive frame. For example, we had the receive connected each other and Terry laptop send broadcast frame to switch 3. Switch 3 send out box 1 and will not send out box 2 because box 2 is a blocking state. Switch 1 receives the frame and forward to switch 2, switch 2 forward to switch 3, and switch 3 will ignore the frame because it's received in the box 2. Box 2 is blocking state. With the processing switch with SPNG implemented will prevent loss in the network. Nowadays, we had 4 versions of SPNG. 3 versions come from IEEE. SPNG, this is the original version, Rabbit SPNG, and multiple SPNG. And Cisco had one version, VLAN SPNG or the VLAN SPNG Plus. SPNG had the bridge protocol data unit, BPDU, or just called the hello message. We switch you to exchange information with each other. Hello BPDU lists root bridge ID, and root code, and some timer values. Whereas bridge ID is important field. Original bridge ID has 8 bytes and consists the 2 byte priority field and the 6 byte system ID. With system ID based on the MAC address on each switch. And later, the IEEE changed the rule. They split the original variety field into the 2 fields. The first 4-bit for priority and the last 12-bit represent the system ID extension. And system ID extension will be replaced by the VLAN IDs on the configuration. So priority is the result of the combination of 2 fields, priority and the system ID extension. The reason for the separation is that version of SPNG such as the VLAN SPNG, multiple SPNG, Rabbit VLAN SPNG, they create a separate SPNG per VLAN. So bridge ID fields is required to carry the VLAN ID information for calculating SPNG for each VLAN. This also requires the command to define the VLAN when we configure the root switch or the baud code on the switch. In the Cisco switch, only priority can be configured, and we can use it to configure SPNG on the network in real environment. SPNG use SPNG algorithm to determine the switch role, baud role, interface status. Generally, SPNG operation will involve 3 steps. Step 1, switch elect the root switch and then the boot on interface of the switch to the forward state, and we call the baud is designated baud. And step 2, each non-root switch consider one each baud has at least administrative code between the itself and the root switch. The code connect the root code and the zip baud will be placed in the forward link state. We call the baud in the root baud. And the final, with the non-root switch on the one link, switch will load it. Root code will be placed in the forward link state, and we call baud is a designated baud. And another switch baud will be placed in the blocking state, and we call the blocking baud. Okay, and now let's explore each process in detail. At the first time, the switch will on waiting its root and send a BPDU with the root code 0 and root bridge ID with default priority 32768. In receive BPDU, switch will check the priority first in bridge ID. Lower priority will win. If priority high, switch will check the system ID or the MAC address. Lower MAC address will win. In case that switch see lower bridge ID from another switch, that switch stop advertise itself as root and start forward the superhero hello. This message lists the lowest bridge ID called root bridge ID. The process will finish after the switch agree which switch has the lowest bridge ID. For example, switch 1, switch 2, and switch 3 has advertised itself as root at first time, and seed 2 receive BPDU from seed 1 and see seed 1 has the best value, lower MAC or rest. So it stop advertise itself, then forward the root brick ID of seed 1 to seed 3. Seed 3 also check the BPDU and see its BPDU is higher than seed 1, so it accept the forward to seed 1 root brick ID. As result, seed 1 will root in the seed network. On board of the rosette will become the designated board and have capability to forward the hello message. Okay, the second rosette and non-rosette join the root board, and one switch has the one root board. Root board is interface with head list code to reach the root switch, call it the root bus code or just the root code. Each board has a default code value which defined by the manufacturer based on some IEEE standard, and it also can be configured. For example, root switch after the root switch election complete, switch 2 and switch 3 is a non-root switch, and they need choose the root board by themselves. Switch 2 has the two bus to reach the root switch 01 via the box 1 and box 2. Root bus code is sum of code of the switch box which the frame will exist if it follows that bus. In those bus, we only care about outgoing box codes and ignore the incoming box code. In the example, if we do the calculation in the switch 2, we just get the box 1 in the box 1 and the box 2 and box 3 on the switch 3 if we calculate on the bus 2. And the root bus code of each box on the switch 2 with total of value of outgoing box for the Z bus. The box with the lower root bus code will become the root box of switch. For example, Cisco also do the same line step. What we analyze, the switch will add the local interface code into the hello BPDU for providing the calculation. We should also check the neighbor root code come from the hello BPDU received from each neighbor switch. For example, switch 1 send hello with the list root code is 0 because it's a root switch. Switch 03 receives the root code 0 and is add the code of the interface which hello world receive, so the code of box 1 is 4. Switch 3 forward the code to the switch 2, and now switch 2 determine total code of box 2 read to root switch is 8. So each choice box 1 is a root box because box 1 has the lower code than the box 2. In this case, the root bus code type switch will use one of three type record. One, choose the root box based on the lowest neighbor bridge ID, priority, and the MAC or rest. And two, choose root box based on the lowest box priority. And final, choose the root box based on the lowest neighbor internal box number. For example, if switch use a brick ID of neighbor to determine the root box. I had the 4 switch connect each other, and switch 4 had the box 1 and box 2. They are all had the same root bus code. So switch 4 will use a MAC arrest or brick ID from the switch 2 and switch 3, and after the comparison, switch 2 rely the brick ID of switch 2 is lower than switch 3, so switch 4 choice box 1 is the root box and box 4 is the blocking box. Okay, the final step in the symmetry process is choose the designated box on the each LAN segment. The designated box on the LAN segment is a box that advertise the lowest code hello into the LAN segment. Designated box election use the root bus code of root box and one type record using bridge ID. When a non-root switch forward the hello, the non-root switch set the root code field in the hello to set root bus code to reach the root switch. In effect, the switch will switch with the lower code to reach the root switch. The switch box will become the designated box. and the remote block is a blocking block. Block has blocking state will not forward the frame and but it still listen and process the hello BPDU. If the root got high, switch block with the logic bridge ID will win. For example, the link between the SID2 and SID3 has the same root code, so SID2 and SID3 will check the bridge ID each other, and SID2 receive its bridge ID lower than SID3, so block 1 is a descending block and block 2 on SID3 is a blocking block. Okay, beside the priority, block code also is a configurable parameter we can adjust when configuring stability on the switch. Block code also has the default values per box or per VLAN. Cisco has long used the default setting as defined back in 1998 version, or just called the A02.1D standard, and the latest IEEE standard suggest the rapid stability default cost published 2018. It suggests the value for the link has factor speed 10 gigabit per second, 100 gigabit, or 1 terabit. We had the one note here. The link code default based on the operation speed of link, not the maximum speed. So we can use command stability passcode method long if we want to apply the default code in the 2018 version. This is also the default setting on the Cisco switch nowadays. Okay, in operation, stability use 3 timer, hello timer, mask A, and forward delays. If a switch does not get expected hello BPDU within the hello timer, the switch will continue as normal. However, if the hello do not show up again with the mask A time, the switch reacts taking step to change the stability topology. With default settings, mask A is 20 seconds, 10 times a default hello timer of 10 seconds. Okay, for example, after engineer configuring stability completely on network, stability on the switch will do some action to check the stable of network. Step 1, the root create and send the hello BPDU every hello timer 2 seconds by default with the root code 0 and out send out on its working interface. Step 2, the non-root switch receives the hello on their root box, and after changing hello lead to the our bridge ID as the sender ID and list that switch records, and then the switch forward the hello out on the sanity box. Step 1 and step 2 will be repeated until the something change on the any switch. Is by the stability election choice again based on any hello is received from outer switch. It evaluates the switch should be a root switch, and if the local switch is not the root, it choose the root box and determine whether it's a designated box on each link. In my case, switch 3 react to change because box 1 fails, and switch 3 rely about that based on mask A timer or interface fails. Because switch 3 still receive hello from switch 2 with the root switch is switch 1, so switch 3 rely is the bridge ID is still higher than switch 1, so it's no, it's not a root switch. And next, switch 3 re-evaluate to the root box because now it's only one box up and receive hello from only this box, so simply box 2 is root box. And additional, if switch 3 has another connected interface, it also re-evaluate the designated port in the interface. Okay, we had a discussion about the root box, designated box, blocking box, forwarding state, blocking state. Stability contain run and state. Run define the run box in the network and like the root box, designated box, and state define started box forwarding and blocking. Normally, symmetry move the block through the 4 stage: blocking, learning, listening, learning, and forwarding. When it's connected, blocking and learning stage, block will not receive or forward frame, but in the listening stage, switch will remove the unused MAC address and child. Learning stage, block also will not forward frame, but switch begin to learn the MAC address for the frame received on the interface. Switch need 20 seconds to move block from blocking stage to the listening stage, and the 30 seconds to change from listening to learning and listening to forwarding, because the block need wait the forwarding and delay timer is by. Okay, now let's do the assemble. Determine where a root switch, root block, and blocks block. I had the 4 switches 1, 2, 3, 4 connect each other, and the quarter block is same in the on switch, and switch 1 had a lower priority. So in the root switch election, switch 1 is the root switch, and after that we need choose the root block of both each switch, and switch 2 had the 2 paths to reach the root switch 1, and block 1 had the root code is the 4, and block 2 we calculate the total the code of outcoming block in the path. So the code is 4 A and tail. So we can see the block 1 had the lower code than block 2, so block 1 is the root block on the switch 1. Similarly, in the switch 3 we had the block 2 is the root block, and in the switch 4 we can see switch 4 had the 2 paths, right? And also we can see the root bus code of each block is same: 4 EA, 4 and 4 EA. So switch 2 will use the brick ID of switch 3 and switch 2, and it's compare the MAC address of each switch and see switch MAC address of switch 2 lower MAC address in switch 3, so block 2 is a root block on the switch 4. And finally, we need to determine the descending block between the link, because link between switch 1 and switch 2, the block had the run already. Also in the switch between the switch 1 and switch 3, so we need to check the link between the switch 2 and switch 4. Block 2 had the root bus code is the 4, and block 2 on the switch 4 had the root bus code is A. It also the root block, so block 2 on the switch 2 had the lower root bus code than the block 2 on the switch 4, so block 2 in the switch 2 is a descending block. And finally, link between the switch 3 and switch 4, block 1 on the switch 3 had the root bus code is the 4, right? And block 1 in the switch 4 had root bus code is A. So block 1 in switch 3 is a descending block, and block 1 in switch 4 is a blocking block. Okay, as via the example we can have the tip if block A connected to the remote block B, and remote block is a root block, then we can determine block A is a descending block. For example, we had the link between the switch 2 and switch 4, because the block 2 on the switch 4 is a root block, so block 2 on the switch 2 will be the descending block. So this is a tip we can determine the root block and descending block more easier. Okay, let's do another example more complex, and we had the 5 switch connect each other. Switch the root code the same, only 4, and switch 1, switch 3, and switch 2 has the same priority 24577. So switch 1, switch 2, and switch 3 will check the MAC address each other, and we see the MAC address in switch 1 the lowest than switch 2 and switch 3, so switch 1 is root switch. Now we need to determine the root block. Same like a previous video, we can determine the block 1 on the switch 2 is a root block, and block 2 on the switch 3, also root block. In the switch 4, now we can see switch 4 had the 3 baht read to the switch 1, right? So let's check in block 2. Block 2 had the root baht code is the 4, let 4 is 8. Block 1 have root baht code is 4, 4, 8. And block 3 had the root baht code 4, 4, 4. So the root baht code is the 12, right? So in block 1 is block 2 need recalculate one more time using the brick ID. Switch 4 will compare brick ID of switch 3 and switch 2 and see the MAC array of switch 2 lower than MAC array of switch 3. So block 2 is the root block. And in the switch 5 we also see the root baht code is same. So switch 5 we compare the brick ID from switch 3 and switch 4, and switch 4 had the higher value than the switch 3, so block 1 on the switch 5 is the root block. Now we need to calculate the designated block using the tip in the previous example. We check the link between the switch 2 and switch 4 and see the switch block 2 is a designated block because it's connected to the root block. Now we check the link between the switch 3 and switch 4. Root baht code of block 1 on the switch 3 is 4, right? And root baht code in block 1 on the switch 4 is 8. So block 1 on the switch 3 is a designated block, and block 1 on the switch 4 is blocking block. Okay. Link between the switch 4 and switch 3. Root baht code of block 3 on the switch 4 is 8, and root baht code in the block 1 on switch 5 also the 8. So switch 1 and switch 4 and switch 3 will check the brick ID, and brick ID of switch 4 lower than brick ID of switch 5. So block 3 on switch 4 is a designated block, and block 2 on, and we can see the block 1 on the switch 3 connect to block 1 on switch 5, and the block is the root block. So the block 1 on the switch 3 is a designated block. Okay. Okay, now let's go to the lab experiment. Let's recall the history. The IEEE published the A02.1W amendment to the A02.1D in the 2001. This is the first standardized rapid symmetry, and the IEEE replaced the symmetry with the rapid symmetry in the revised A02.1D standard in 2004. After that, in 2011, the IEEE removed all the rapid symmetry detail into the revised A02.1Q standard, and it stands today. Rapid symmetry actually is covered in the A02.1Q standard document. In the real time, we often use term symmetry to refer the original symmetry and rapid symmetry for the all revised version. Actually, we really care which correct version of symmetry implemented on the switch. Okay, so what difference between the symmetry and rapid symmetry? They are published by the IEEE, and rapid symmetry has a factor conversion compared to the symmetry. This is why the IEEE replaced the original symmetry with the rapid symmetry. And to achieve about that, the rapid symmetry adds new mechanism to replace the designated block and root block without any waiting to reach a forward state using the backup block and alternate block. Rapid symmetry also defines the mask A as the 3 times of hello timer instead 10 times of hello timer in the symmetry originally. Rapid symmetry use name of change the name of blocking state to discarding, and rapid symmetry avoid waiting on the supplementary time, resulting in quick transition from forwarding to discarding block state and vice versa. In additional, rapid supplementary and supplementary switch select their root block, the synthetic block with same rule and tiebreaker. Rapid supplementary use different terms for the block rows, alternate and backup. Alternate block is a backup option for the root block if the root block fails, and backup block is provide a backup option for the synthetic block. With rapid supplementary, it should immediately generate its own hello, and additionally, rapid supplementary allows the fault query between the neighbors rather than waiting on timer or to expire. Admin to avoid waiting time to learn information and achieving the faster conversion. Okay, let's explore what is the alternate block and backup block on rapid supplementary. An alternate block basically works like the second best option for the root block, and the block which row alternate is in blocking state. Anytime the root fails or when the root block did not receive the hello, switch will change the rows and state of the block. For example, the link between switch 1 and switch 3 failed, so root block in the switch 3 will not receive the hello. Switch 3 will change state of block 2 to root block and switch 2 now started with the rapid supplementary message. Switch 2 will plot the mark red and J. Switch 3 also change the block 1 to disable started and transition block 2 to forwarding state immediately without the learning state. And the backup block same like the alternative block. This is the option for the alternates have the quickly replace the switch designated block on the sum lane. We need for the backup block in scale design has the switch connect to the hub. In this design, the switch connect to the more than one block to the same collection domain. Same like the the alternative block, the backup block is a blocking state. And I think nowadays this design is not useful anymore and should be avoided using the backup block. Rapid supplementary has learning and forwarding state same like original supplementary, but it does not define the listening state, and it's renamed blocking state to discarding state. Discarding state defines the two states, blocking and disable it. Blocking state is stable, can work physically, just cannot forward user frame. Disable state is stable, is shut down by user or no connection. Rapid supplementary avoid relying on the timer for achieving the factor conversion. Rapid supplementary switch tell the each charter using the message that the topology will has changed. Those the message tell neighboring switch to float content of their MAC or rest. In that way, remove all the lock causing entry without waiting. As research, rapid supplementary create more scenario which discard block can immediately transition to the forwarding state without waiting and without using the learning state. Rapid supplementary also defines some term for the block type corresponding how it's connected. If the block connect to the two switch and they is called the boy-to-boy box, and if the block connect to the endpoint device, it called the boy-to-boy S block, often just called the S block. And finally, if the block connect to the hub, we call block the C block. Okay, Cisco support the three version, supplementary version, per VLAN supplementary, multiple supplementary, or rapid per VLAN supplementary. Per VLAN supplementary and rapid per VLAN supplementary support the one supplementary per the one VLAN, and the multiple supplementary support the multiple instance for VLANs. Eventually, Cisco does not implement rapid supplementary directly. Instead, it had the rapid per VLAN supplementary version, which refer method of rapid supplementary. But there are some different. For example, rapid per VLAN supplementary support supplementary for each VLAN instead of one supplementary per all VLAN of the rapid supplementary. A new Cisco Catalyst switch using Rabbit binary, Rabbit VLAN binary as default binary mode. And in configuration, we can change binary mode on the switch using command binary mode follow the mode we want. VLAN binary, Rabbit VLAN binary, or the multiple binary. And we can use click command clear binary detect the protocols to restart reset in the binary. And in Rabbit VLAN binary, Cisco provide two ways to configure the root switch. Option 1, we can use the priority, and another using primary and secondary to define which switch is root switch and which switch is the backup of root switch. In this case, if root switch fail, the switch will take over root switch role, and priority has range from 0 to 61440 is multiple of 4096. Totally, we had 16 value available list as in the table. If we input the different value, the switch will inform the command is wrong. So we can change the code of interface using command binary VLAN, follow VLAN ID code and follow the code. This command will modify the VLAN code on the trunk block. The current had the range from the 1 to the 2 million. Default value will got from speed of the interface. Higher value mean the lower speed transmission. Cisco recommend use binary VLAN root primary and secondary command instead to modify the switch priority in practice. The primary key keyword automatically set the priority to value 24576 or the value below the lowest priority detect on the network, and the secondary key set priority to the value 28672, assuming that the rest of network set to default priority. Okay, in operation we can modify the timer of the binary. Hello timer, forward timer, and the max A. Hello timer has the range from the 1 to 10 seconds and default is 2 seconds. We can change using commands binary VLAN follow VLAN ID, hello time, and follow the second. Forward timer also using the same command, just replace the forward time by second. And the forward time range is range from the 2 seconds to the 30 seconds, and the default is 15 seconds. The max A range has range from 6 seconds to the 40 seconds, and default is 20 seconds. Okay, binary had some feature both fast and PPD Yuga. Both fast allow switch to immediately transition from blocking to the forwarding by listening and learning stay in binary. Both fast almost apply to board connect to user device and should not apply the board fast to the board connect to the another switch. It will create loops. If we turn on the board fast on the board connect to the end user device, when the device user boot, the switch board can move to the board to forwarding state and forward traffic as soon as the NIST is active. Without the board fast, each board must wait while the switch confirms the board is a designated board. Rabbit binary include board fast if we use if we define the board is as board using command portable as board. And the PPD Yuga, this is the Cisco feature and help defeat the kind of problem by disabling a board if any PPD Yuga receive on the board. The PPD Yuga should be used only on a set board and never apply the filter to the board connect to the another switch. PPD Yuga can prevent the problem with board fast. If any BBDUGA message received on the box, the local switch will move back to the error display status and prevent the loss immediately. To enable the BBDUGA, we can use command 73 BBDUGA enable under the interface submode, or we can use the command 73 box BBDUGA default on the under the configure mode, and this command will enable the BBDUGA feature on the all interface configure in the access mode. Okay, we complete the topic today. I think it's a long topic, right? But very important in networking. Thank you for watching and see you in the last video. I hope get your like and your subscribe my channel, friends. Bye bye.